So welcome guys to Syllabus Cracker. Today's video we will be doing a chapter called Chemical Changes and Reactions. As a reference, I will be keeping my textbook. That means I'm not fully teaching a textbook from my knowledge plus the textbook knowledge I will be teaching. So according to latest syllabus prescribed by Icse, after 25% reduction of portions in July 2020 for the 2021 examination, the portions are you have introduction. Introduction includes what is the definition, chemical bonding, and representation of chemical equation, and types of chemical changes. You have to study in detail, not all portion, but still. After that, we have energy changes in a chemical change: exothermic, endothermic, photochemical, electrochemical. That's all. Even though portions are very few, the chapter is a little bit like extended chapter. Don't worry, you can carry on. So without any time waste, let's start the chapter. So if you're new to this channel, also subscribe the channel because this is the first video, so everyone is new. Also like the video if you liked it. So first topic is introduction to a chemical reaction. What is a chemical change? It is a permanent and reversible change in which a substance changes into a new substances, and you cannot recover the new substances even though you apply any external uh, sources. In some cases, external sources are you can also use it. Okay, so what is a chemical reaction then? A chemical reaction is a chemical change in which a matter changes into a new substance or substances. So you will be having a particular two elements or compound, and if you make them react by any sources, then it will react and you will get a new substance or substances which may be reversible. You cannot completely say because some are irreversible due to that. Okay, so in a chemical reaction, the substance or substance taking part in it, the substance which take part in chemical reaction, they are called as a reactant, while the result that we get in a chemical reaction or transformed into one or more new substances, they are called as products. So let us take a simple example. In this textbook, I have N2 plus CaOH twice plus 2HNO3 balanced equation. You know what is a balanced equation? CaOH twice plus 2HNO3 gives CaNO3 twice plus 2H2O. Here you have a main arrow in between. Main arrow. What is the use of the arrow? It indicates the direction of the reaction. It indicates the direction of the reaction. We are having left hand side, that is CaOH twice plus 2HNO3. That is the left hand part of this reaction. What is the use of this? So what is the use of this is that this substance, this take part in a chemical reaction and we call it as a reactants, and it gets transformed into new substance, that is CaNO3 twice plus 2H2O on the right hand side, called as products, which is formed after the chemical reaction. Understood? You must focus on the LHS part, reactants, and the importance of arrow and the right hand side. Also, this CaOH twice plus 2HNO3 gives CaNO3 twice plus 2H2O. It is molecular equation. Now what about word equation? We write in words such as, what is CaOH twice? Calcium hydroxide plus nitric acid. Do not balance because we cannot write 2 nitric acid. You cannot write. It is cross. Just write a nitric acid. You can also mention it is dilute or not. This is dilute nitric acid. How will you mention? After writing nitric acid, put on a bracket, put DIL dot. DIL dot indicates dilute. Gives calcium nitrate plus water. Don't mention 2 water, simply water. It is wrong. Clear? So that was representation of chemical equation during a reaction. Next, you have to focus on a bond and chemical bond. So you have your own best friend, yes. So your best friend and you may share lunch, share snacks. You spend time together in free periods in school. Not now because of lockdown. So actually there is a bond between you both of them that helps doing these type of works. So we in normal work we call it as a friendship bond. Like in chemistry, between two elements, two atom of an element, there exists a bond even though during a reaction. It is called as chemical bond. So there is a particular definition: the linkage of force which act between two atoms of an element to hold them to be together as a stable molecule. There's no need to mention stable molecule. You must mark the point, the linkage of force between two atoms of which acts between two atoms to hold them together. So to be a stable molecule is called as a chemical bond, and the concept of chemical bond or bond we say it as chemical bonding, which we will learn later chapters in this textbook, and you will learn in detail in 10th standard also. Okay, so that is interaction part. Clear? Next, type of chemical reactions. Chemical reactions are of four types: direct combination, displacement, decomposition, double decomposition. We have four types. So direct combination is a chemical reaction in which two or more elements or compound react together to form a one new compound. Okay. Decomposition reaction means a chemical reaction in which a chemical compound decomposes into two or more simpler substances. Okay. So what is the difference between these two? First one we can say A plus B gives AB, while second one, that is double decomposition reaction, it is AB gives A plus B. Not the difference? Two of them you can say it is exactly each other in mathematical statement, but in chemistry you cannot say like that. You have two different definitions, so focus on that. Okay. Displacement reaction. So displacement, displace. Yes. A chemical reaction in which an element or radical displaces another element from its compound. For example, A plus BC. A displaces C, AC, and you will get as AC plus B. What about double displacement? Yeah. It is a chemical reaction in which two reactants are both decomposed to form a new substance by exchanging the radical. It means AB plus CD gives AD plus CB. Instead of B, it takes D and the other with that CB. Not BC. Why? B is a non-metal. You cannot start with a non-metal like that. Okay, you cannot write OH2. Okay, you cannot write water OH2. You cannot write. You can write H2 only. First metal, then non-metal. Even though hydrogen is a non-metal, it's an exception case while writing a periodic table. That is why it is like that. Clear? So let's study each type of reaction in detail with the examples. First one is direct combination reaction. What is the definition? A chemical reaction in which two or more elements combine together to form a one new compound. So it can be two elements combined together to form a one compound. For example, C plus O2 gives CO2, carbon oxygen, carbon dioxide. It can be one compound and one element giving one compound. For example, carbon monoxide and oxygen gives carbon dioxide. In balanced form, it is 2CO plus O2 gives 2CO2. I have to write and balance it. I cannot say normally balanced. Okay, that is why I'm looking into here. And it can be a compound which combine with another compound to form a compound. Compound plus compound give compound also is there. Carbon dioxide and water gives carbonic acid. CO2 plus H2O gives H2CO3. Not the difference. Gas plus liquid gives gas. So there are special characteristics also. You can say if you say H2 plus O2 gives H2, 2H2 plus O2 gives 2H2, it is liquid and liquid giving a gas. So keep the logic in your mind. I'm not saying everyone, but I just mentioned it. Okay. Then okay, so let's look at more. Oxidation of metal. What do you mean by oxidation? Yeah, adding oxygen to that substance. Oxidation of metal means adding oxygen to metal, metallic oxide. So there are three metals, three main metals. What are they? Sodium, calcium, magnesium. So let's oxidize these three metals. Or sodium plus oxygen is sodium oxide. So Na plus O2 gives Na2O. That is in balanced form. It is 4Na plus O2 gives 2Na2O. Okay. Next is calcium. Ca plus O2 gives CaO. Not Ca2O. Why? Because both of the valencies are 2. You get cancelled and become CaO. 2Ca plus O2 gives 2CaO. Okay. Next is magnesium. Mg plus O2 gives MgO, magnesium oxide. 2Mg plus O2 gives 2Mg. So when you treat this metallic oxide with water, you will get metallic hydroxide. So what are the three metallic oxide? Yeah, Na2O, MgO, CaO. So MgO plus H2O will give MgOH twice. And there is no balancing over 3. Okay, Na2O plus H2O gives NaOH. Why not twice? Because valency of sodium is 1, so that's why. Sorry. And hydroxide is also 1. Next is CaO plus H2O, calcium oxide and water. Calcium hydroxide, CaOH twice, because once valency is calcium is 2 or hydroxide is 1. So metal plus oxygen gives metallic oxide. Metallic oxide plus water is metallic hydroxide. Simple? Is it simple? I hope it is simple. Next is non-metal, not oxidizing the non-metal. That is non-metal plus oxygen. It is a non-metallic oxide, or we say it as an acidic oxide. So there are three non-metals here also: sulfur, carbon, phosphorus. S plus O2 gives SO2. C plus O2, CO2. What about P plus O2? Is it PO2? Phosphorus oxygen? No. It is phosphorus pentoxide, P2O5. Okay. S plus O2 gives SO2. C plus O2 gives CO2. Both of them are balanced. But the third one, 4P plus O2 gives 2P2O5. Don't get confused. Here also, PSO, non-metal plus oxygen gives non-metallic oxide or basic oxide. If you treat that with water, you will get acid. That is, what are the three basic oxide? NO2, SO2, P2O5. So SO2 plus H2O gives H2SO3. Sulfur dioxide plus water is sulfurous acid, not sulfuric. Sulfuric is H2SO4. Here we have H2SO3. Yes, yeah. Sulfurous acid. SULPHUROUS. Next is CO2 plus H2O. H2CO3, carbonic acid. And what about phosphorus pentoxide? Phosphoric acid. So P2O5 plus 3H2O gives 2H3PO4. Clear? So that is about few examples. Next, preparation of few metals and normals. That's normal. How will you prepare FeCl3? So you will add iron and chlorine, you will get FeCl3 in soluble salt. You must be able to know preparing of one soluble salt. It is important. 2Fe plus 3Cl2 gives 2FeCl3. Okay. Now, other examples, burning of hydrogen. How will you burning of hydrogen with oxygen? That is 2H2 plus O2 gives 2H2O. Plus exothermic reaction that we will learn later at the end of the video. We will discuss about that. Next, how will you manufacture ammonia? NH3. How will you manufacture ammonia? What is the formula of ammonia? NH3. How will you manufacture NH3? It is clear. N and H are there. Nitrogen and hydrogen. True. N2 plus 3H2. Not. It is a reversible reaction. Gives 2NH3. Why reversible? Why reversible? Suppose you can do A plus B gives AB. If you heat A and B, you will get AB. But if you cool AB, you will get A and B. So if you do 1 plus 1, you will get 2, and you can write 2 as 1 plus 1. So they both are reversible. You can do it any manner. So there are few conditions. This process is called Habers process. Manufacture of ammonia, it is called as a Habers process. HABER. There are conditions, that is temperature must be 450 to 500 degrees Celsius. So hot, yes. And the pressure must be 200 to 900 atmosphere, and catalyst finely divided iron. Three conditions. What are they? First of all, if somebody asks you how will you manufacture ammonia, you must write the equation. In 2 plus 3H2 gives 2NH3, reversible also, okay. And the temperature must be between 450 to 500 degrees Celsius. What is the atmosphere? That is what we call pressure, 450, sorry, 200 to 900 atmosphere, and the catalyst finely divided iron. How will you prepare sulfuric acid H2SO4? So, how will you prepare sulfuric acid? How we prepare sulfuric acid? We took SO2. So here we SO3 plus H2O gives H2SO4. Sorry. Sulfite and water gives sulfate. Sulfurous. Sulfate and water gives sulfuric. So, how will you prepare hydrogen chloride gas? Hydrogen chloride. H2 plus Cl2 gives 2HCl. Condition is that diffused sunlight. You must need diffused sunlight. Not the point? And the reaction must be directly explosive in the direct sunlight. What is the catalyst over here? Catalyst is moisture. In ammonia, catalyst is finely divided iron. Here in preparation of HCl, we need diffused sunlight and catalyst as moisture. H2 plus Cl2 gives 2HCl. We prepare ammonia. Yes, how will you prepare ammonium chloride? What is ammonium? NH4. How will you prepare ammonium chloride? You will need ammonia. First of all, you need ammonia. NH3 plus HCl give NH4Cl. NH3 plus HCl give NH4Cl. So ammonium chloride is formed by combining the vapors of ammonia with hydrogen chloride gas. So you have to prepare ammonia, then hydrogen chloride, then ammonium chloride. Got the point? After that, you need formation of ammonium sulfate. You will need ammonia and sulfuric acid. That is NH3 plus H2SO4 give NH4 twice SO4. Next is preparation of ethylene and ethane. What is ethylene? So ethylene will look. So first of all, acetylene. Acetylene is it is a type of it belongs to a part of organic chemistry. So this acetylene, ethylene, those things consist of carbon and hydrogen, only carbon and hydrogen. That belongs to organic chemistry, which we will learn on 11th chapter if you are still ICS and taking chemistry. Now, coming back. So, preparation of ethylene. So, first of all, acetylene. Formula is C2H2. C2H2 plus H2. So, C2H2 acetylene plus hydrogen gives ethylene C2H4. Next is preparation of ethane. For that you need ethylene. They prepared ethylene. So C2H4 plus H2 gives C2H6. Is this interesting? Why? Listen. First of all, we took acetylene C2H2. Yes. C2H2 plus H2. We took C2H4 ethylene. That ethylene plus hydrogen, that is C2H4 plus H2 gives C2H6. So it is equivalent of steps. First of all, we will add hydrogen to acetylene to give ethylene, and you will further add hydrogen to ethylene to give ethane. Clear? So many preparation. We first of all we looked at preparation of FeCl3, then burning of hydrogen, manufacture of ammonia, condition 450 to 500 degrees Celsius, pressure 200 to 900 atmosphere, and what catalysis finally divide iron. Then we looked at sulfuric acid, hydrogen chloride gas, diffuse sunlight, moisture is the catalyst. After that, ammonium chloride. After that, ammonium sulfate. Then ethane. Preparation of ethane by preparing ethylene. So we are done with direct combination reaction. Direct combination reaction is also called as synthesis reaction. Okay, synthesis reaction. It is also called as synthesis.